Problem 3-40. The spring has a stiffness of 800 newtons per meter and an unstrength length of 200 millimeters. Determine the force in cables BC and BD when the spring is in the position shown. So if we draw a free body diagram here, I'm going to call this force C from B to C. And this is force D from B to D. And that's force A from B to A. Now force A is equal to the force of the spring, which is equal to the spring constant, 800, times the stretch. And the unstretched length is 200, and the total length is 500, so the unstretched length is 0.3 meters. And so the FA is equal to 240. FB is, so this is a 300, this is a 400, so this is a 3, 4, 5 triangle. So FB is going to be in the X direction, it's going to be -4/5 FB. And in the Y direction, it's going to be -3/5 FB, or 0.8 and 0.6. FC is a 400 and 400, so that's a 45-degree angle. And so we know it's going to be -0.707 in the X FC, and it's going to be +0.707 in the Y, the J. I could put my I's and J's here. This one is all I, isn't it? Okay, so if we sum the forces in the X direction, we get 0. And that's 240 minus 0.8 FB minus 0.707 FC. Sum the forces in the Y direction, we also get 0. And in the Y direction, we have -0.6 FB and plus 0.707 FC. So let's rearrange this one right here. I'm going to move the -0.6 of this side and divide by 0.6. So FB is equal to 0.707 divided by 0.6 FC. And so that's 1.18 FC. Now let's take this down here. I'm going to move these two to the other side, and so they become positive. So 240 equals 0.8 FB, which is 1.18 FC, minus, not plus because we moved it, 0.707 FC. So we multiply that and then combine, and we get 240 equals 1.65 FC, and then FC is equal to 145. And that's going to be newtons. Putting 145 into there, and FB is equal to 171 newtons.